Okay, water heater uses natural gas to heat 180 liters, which would be 180 kilograms, right, of water. It's initially at 20 Celsius, right, and the heater has an efficiency of 54%. What is the final temperature after it's burned 0.5 kilograms of natural gas? Well, here's the idea, right? Our final temperature is going to be our initial temperature plus the delta T, right? And our delta T, is going to be from this, right? Delta T is Q over MC, okay? And we know that the mass is 180 kilograms. We know that C is 4186, right? Okay, but we got to figure out the Q, the heat that goes into the water. So what that heat is going to be, by the way, is 54% of the heat released by burning this. Okay, so the heat released by burning 0.5 kilograms, right? So mass times specific energy, that's going to be 0.500 kilograms. And then let's see, it's a natural gas, right? So that's this guy here. That's going to be 55 times 10 to the 6th, and that's joules per kilogram. So let's figure out the heat released by this. And then 54% of that goes into the water. So we'll figure that out. So 0.5 times 55 E6. And that is, of course, 2.75 times 10 to the 6th joules. All right. So now we know the energy that is released by burning that, right? And now the heat that goes into the natural gas, this is our output, right, is going to become our Q. That's going to be 54% of that. That's what 54% efficiency is. So 0.54 times 2.75 times 10 to the 6th. And what I just did there, by the way, is I just did this. Okay, if efficiency is output over input, then output is efficiency times input. This is our input. This heat that goes into the water is going to be the output. Okay, so 0.54, 54% of that is 1.485 times 10 to the 6th joules. Okay, so this is heat released by burning. This is the heat that goes into the water, and of course the rest of the heat is just wasted. It goes up the flue or something like that, or or isn't, possibly the natural gas doesn't combust completely, right? So now we're set. Now we can figure out the change in temperature. That's going to be this heat here. That's what actually gets into the water. Divided by the mass, which is 180 kilograms. Times the specific heat, 4186. Now I hope you understand what's going to go on here, right? The kilogram cancels the kilogram. The joule cancels the joule, and you end up with 1 over degrees Celsius. So we'll end up with degrees Celsius. So this guy divided by the left parenthesis, 180 times 4186 right parenthesis is 19.7 degrees Celsius. Okay. So our final temperature is, what's our initial temperature? 20 plus the 19.7 degrees Celsius is 39.7 degrees Celsius. Ta-da! So just, yeah, anyway, it's a little bit tricky. Not too tricky.